What is the AAS congruence rule? The AAS, or angle-angle-side congruence rule, states that if two angles and a non-included side of one triangle are equal to the corresponding angles and the corresponding non-included side of another triangle, then the two triangles are congruent. The term non-included means that the side is not between the two angles. Let's place the AAS congruence rule in one of our rule boxes and save it for later. Take a look at triangle ABC and triangle DEF. If you know that angle A equals angle D and angle C equals angle F, while side BC equals side EF, then you know that the two triangles are congruent. But how do you know that the two equal corresponding angles and an equal non-included side is sufficient to determine congruence? Let's take a look at an example. Start off with three line segments of random length. You call one line segment AB, the other BC, and the last AC. First, let line segment AB be intersected by line segment BC at an angle of 47 degrees. Now, let line segment AC intersect AB at an angle of 56 degrees. The shape of the triangle is now set, but the size is still undecided. If you fix line segment BC at length 3, then the size of the triangle is determined. The same is the case if you fix line segment AC at a given length, say, 7. The size of the triangle can be determined in this way, too. There is only one triangle that satisfies either of these criteria. So, if you have two triangles and want to check if they are congruent, it is sufficient to check two angles and one of the two non-included sides. Let's look at an example. These triangles seem to have the same shape and size, but you cannot be sure. In both triangles, you have information about this corresponding angle and this corresponding angle with this non-included side. Angles A and D are both 50 degrees and are therefore equal. Angles C and F are both 100 degrees in both triangles, so these angles are also equal. Finally, the sides CB and FE both have a length of 7, meaning that they are equal as well. Based on the AAS congruence rule, you can therefore conclude that these two triangles are congruent. Despite knowing nothing about the length of the two remaining sides or the size of the third angle, the AAS congruence rule has helped you conclude that the two triangles are congruent in this case. Now let's look at a final example. These triangles appear congruent. Let's see if you can use the AAS congruency rule to confirm this. For triangle ABC, you know that angle A is 45 degrees, angle C is 65 degrees, and that side AB is of length 4. In triangle DEF, you are missing the corresponding information about side DE, even though you have information about the other non-included side, EF. In this case, you cannot use the AAS congruence rule. You always need the exact corresponding sides and angles in the two triangles to determine congruence. The AAS, or angle-angle-side congruence rule, states that if two angles and a non-included side of one triangle are equal to corresponding angles and the corresponding non-included side of another triangle, Then the two triangles are congruent.